Hey, it's Dave. So yesterday there was big news for Tesla FSD or full self-driving. FSD version 12, if you don't know already, is Tesla's upcoming rewrite of their full self-driving software. Previously, Tesla relied on over 300,000 lines of C code to largely put guardrails around FSD and give instructions on how to drive. But in version 12, Tesla shifted their approach to an end-to-end neural net approach, which means rather than dictating how the car drives by instructions, Tesla is letting a neural net AI determine how to drive on the fly. I'll explain more on this and why it's important. But last night, Tesla rolled out its FSD version 12 software to a very small number of non-Tesla employees, and one of them was Omar from Holmar's blog, who covers Tesla on X. In this video, I wanted to share my reaction and thoughts to his initial drives with FSD 12. Alright, so first off, it's a huge accomplishment for Tesla to give a non-employee FSD 12. It means that they are confident enough with the current iteration to let people see it drive. And now this is a big deal because of how monumental the FSD 12 software rewrite is. In fact, it's something that's never been done before at this scale or ambition, at least that I know of, where something as difficult as driving has shifted from using heuristics or rule-based coding to a neural net end-to-end approach. This is impressive, and in order to understand why, we need to understand why the heuristic code was there in the first place. Now, over the years, Tesla shifted their perception code to neural nets, and it's already been running almost all neural nets for a while. Perception means the part of the code that perceives the world, or in other words, analyzing mostly video, along with how the car is moving. But there's another big part of driving, and that is planning. Even if you see the world around you, you still need to figure out how to navigate that world. And Tesla was trying to cautiously move over that part of the code to more neural nets. And they've been doing so. It's just that it's really hard to get rid of all those rules you put in place. And it's because the rules are there for a good reason. Without those rules, the car might do something really dangerous and get into an accident. And there are a lot of rules, countless, and for a ton of situations. Here's my speculation. As Tesla tried to move rule-based coding to neural nets with planning, they encountered a lot of challenges, and it was slower than what they hoped for. Take away some rules, but then it introduces these unguarded situations that neural nets need to handle. But what if they can't handle those situations, or there's new situations that are created by the absence of the rules that you took away? It's all extremely complicated, to say the least. But we know from Isaacson's biography of Elon Musk that over a year ago, Tesla started to experiment with an end-to-end full self-driving approach. Forget coding all the rules, just use neural nets, not just for perception, but also for the complete planning process. In other words, get rid of all the guardrails and see if neural nets by themselves can figure out how to drive safely and better than any previous FSD version. As Tesla tested this out, the early results were promising, and the more they tested, they realized that this was the way to go. They decided to go all in earlier last year. My guess was probably sometime around spring, I think. But then you got this monumental task of building and training a massive neural net with the right data to make sure it could drive safely. The video data they need to do that is just massive, and the compute required is massive too. That's why Tesla increased their compute goals last year. It's so that they can go all in with end-to-end neural nets for FSD. Now, the big challenge, in my opinion, is to get to a first version that's good enough for customers to actually use. The reason why this is so hard is because of how big the jump is from rule-based FSD planning to a purely neural net-based planning. The jump is huge, and the new neural net planning approach needs to be as good as the old code-based one, or else it's not safe to roll out to customers. Here's another way to look at it. You've got thousands of rules in place to make sure the car doesn't get into accidents. And if you take them away, then the car really needs to know how to drive by itself without those rules. All the crutches come off, and then you're left with the true driving ability of the AI. But that's hard because why did Tesla need all of those rules in the first place? It's because it needed those rules to prevent dangerous mishaps. So in order to get rid of all those rules, then FSD needs to go through a huge jump in ability, probably the biggest jump in its history. It needs to somehow get to a place where it can drive without thousands of hard-coded rules and figure out driving from millions of video clips and figure it out in such a way that it can drive better and more safe than it did with all those rules. It almost seems like an impossible task. That's why any customer rollout of FSD version 12 is such a big deal. Even though the first version, rolled out to Holmar's blog and a few others, is far from perfect, it shows that Tesla has figured out its end-to-end neural network approach enough where it can handle most situations. Now the question is, what is version 12's current weaknesses and how long will it take to fix those? And ultimately, how long will it take to get to unsupervised FSD and robotaxi? Now, on the second question, I think we need to see more of FSD version 12 progress over the next several months to get a better feeling of how fast Tesla is able to improve version 12's driving abilities. My hunch is that we're going to see sizable leaps in abilities as Tesla brings on larger compute clusters for training. I think they'll need all the compute training that they're bringing online this year and probably even more. But how about current weaknesses? In Omar's tweets, he did share how FSD handled a lot of situations amazingly. However, there are times where it would just stop with red hands and basically give up. Now, I interpret that as there's a confidence level where the neural nets have a certain level of confidence to handle situations. And if that confidence level drops below a certain threshold, then it's taught to basically give up and hand control over to the human. It's a safety feature where they don't want the neural nets to hallucinate and just make up a path to drive when it has low confidence. In other words, there are still guardrails with FSD. It's just that they aren't thousands of rule-based code. Rather, it's probably some training to the model where when confidence level drops below a certain threshold, then it shouldn't push it and continue in that situation. And that's a reasonable rule, especially for the time being. Now, the challenge is going to be to increase FSD version 12's driving ability so it rarely ever drops below the threshold of confidence. In other words, Tesla is going to need to feed a lot more data into the neural nets and also improve the neural nets to the point where it can drive dramatically better than this early version, and so much so that it's night and day. Tesla version 12 needs to get to a point where it rarely ever holds up red hands and gives up control to the driver. Rather, the neural nets need to improve to a point where it's confident in practically every driving situation, even complex ones. And that's the challenge Tesla's FSD team has this year, is to radically and quickly improve FSD's abilities through data training and improvements with their neural nets. It's a challenging problem for sure, but one that I think has a clear path on how to improve it. They basically need a lot of data. They need a lot of compute and they need a lot of improvements, right, to their neural nets. That's what Tesla's FSD team is laser focused on this year, and it's going to be exciting to see the results. Hopefully, we'll see some fast improvements and some amazing performance out of FSD version 12 this year. All right, take care everyone. We'll see you guys in my next video.